Now in this sum, we are being asked to integrate within the limits -1 and 3/2 mod of x sine pi x with respect to x. Now we are already aware of the property of the modulus function. Mod of x is equal to x if x is greater than equal to 0, and it is minus of x if x is strictly less than 0. That means that the thing placed here is already greater than or equal to 0. We get the same thing as our answer. But on the other hand, if the thing placed here itself is negative, so final answer is minus of that x. So remember, mod is never negative. Now it is our job to identify the portions of this interval between -1 and 3/2, where x sine pi x assumes a positive sign and where it is assuming a negative sign. So the best thing, I told you earlier also, that whenever there is a modulus sum in case of definite integrals, the very first step to start with is to equate the expression inside the modulus to 0 and get the value or values of x from there. So we have x sine pi x, I equate it to 0. So solving, the very first possibility is x equals to 0. So this is a value of x, so we save it. Likewise, the second possibility here is sine pi x equals to 0. Now here you need to have previous knowledge of the trigonometrical equation that when sine theta is equal to 0, then that theta is equal to n pi, where n belongs to set of integers. So in place of theta we have pi x. So theta, that means pi x is equal to n pi, where n belongs to set of integers. So this pi x is with us. This is pi x, and this is equal to n pi as per the solution. Now this pi gets cancelled, so we get x equal to n, where n is an integer. Now what do we need to do with this x equal to n? N is an integer. I will start giving n values of my choice, and corresponding values of x will be obtained, and I have to pick or take into consideration those values of x which lie between -1 and 3/2, right? So n is equal to 0 gives us x equal to 0, and we already have taken x equal to 0, but 0 is a value. So now n is equal to 1 gives us x equals to 1, because x is equal to n, and this 1 is very much a part means a portion, an element between -1 and 3/2. Now if I take n is equal to 2, we get x equal to 2, but this 2 exceeds 3/2, so this must be discarded. So as of now, we get the values 0 and 1. Now just observe, if I write -1 over here, if I write 3/2 over here, I have two values. One of them is 0 and the other one is 1. So these values are between -1 and 3/2. And using the fourth property of definite integral, which helps us in writing the entire integral as sum of smaller fragments. So what I'll be able to write for this integral is -1 to 0 mod of x sine pi x plus, then from 0, between 0 and 1, mod of x sine pi x, and then between 1 and 3/2, mod of x sine pi x. So this way we get 3 integrals. The next job is to identify the nature of x sine pi x over each interval, each of the 3 intervals. We have start with the first interval here, means this one. Now how exactly we need to do it? Just observe. For the first portion, x is in between minus 1 and 0. So I write x is in between minus 1 and 0 here. So obviously when x is less than 0, x is less than 0 means x is negative. I need to talk about the nature of sin pi x because sin pi x is not in product with x. So again I'll be writing x lies between minus 1 and 0. The x that you see here, it is attached with pi, so I multiply both sides by pi. So we get pi x. Since pi is a positive constant, so if you multiply this inequation by a positive constant, sign of inequality will remain the same. So pi x, the angle, is in between minus pi and 0. Now sine is operating on this pi x, and this pi x angle lies between minus pi and 0. If you recall the graph of sine between minus pi and 0, it is like this. This is the portion of the graph between, this is minus pi and this is 0. So you can see the graph is below the x-axis between minus pi and 0. So this is the graph for sine x. So we can write sine pi x is negative. Now x is negative, sine pi x is negative, and here we have product of two negative things. X and sine pi x both are negative. Negative multiplied by negative makes it positive. So the very first portion of this integral is the highlighted one. This becomes minus 1 to 0 because minus minus makes it plus. This is already positive. So simply remove the mod and write x sine pi x dx. Right? Now, if we wish to deal with the second portion, we have x sine pi x here between 0 and 1. Let's take this into consideration. When x is in between 0 and 1, what do? X is greater than 0, obviously, so that's x is positive. And I need to talk about sine pi x. Again, I'll be writing x is in between 0 and 1. And this x is being operated, means it's in product with pi. So I multiply it by pi, we get pi x, pi over here, and pi into 0 is 0. Now this time pi x is in between 0 and pi. So, and I need to talk about the sine of that pi x. So the graph of sine, if I extend it further, you can see this is between 0 and pi. This is the graph, and you can see this graph is totally above the x-axis, thereby giving it a positive value. So I can write sine pi x is a positive number. So here for the second integral, x multiplied by sine x is positive, sine pi x is also positive. The product is also positive. Positive multiplied by positive makes it positive. So if you look at this second portion of this integral, this portion, so simply mod is going to be removed and x sine pi x is already positive. So I'll be able to write 0 to 1 x sine pi x dx. For the second portion, I think it is also visible through the graph. Now the last portion where we need to justify. The last portion has the limits between minus 1 and 3 by 2. And again, I have to talk about the nature of x and pi x. So if I write x is in between 1 and 3 by 2, then obviously x is greater than 1, then it is positive. X is greater than 1, so x is positive. I need to talk about the nature of sine pi x. Again, I write the same limits of integration between 1 and 3 by 2. This is x. This x is attached with pi. So as usual, I'll be multiplying through it by pi. We get pi x, pi, 3 pi upon 2. Now, I need to talk about sine of this pi x when this pi x, angle pi x lies between pi and 3 pi by 2. If I extend the graph, I'll just draw it over this portion only. If I extend the graph like this, it is going to be like this. This is 3 pi by 2 somewhere here. And this graph that you can observe is below the x-axis, thereby giving a negative value to sine pi x. So we have sine pi x is less than 0. X is greater than 1, x is positive, but sine pi x is negative. That means the two things being multiplied together inside modulus, one of them is positive and the other one is negative. So the product is going to be negative, and when mod is operating on something which is already negative, when we remove mod, we place a negative sign here. So I can adjust that negative sign in between the integrals also. I place a negative sign here, 1 and 3/2 here, and this x sine pi x dx. Now this is how we have to split and we have to justify the modulus sign to get these final integrals. After that, just observe we have x multiplied by sine x appearing in all the three integrals. All you need to do from here is to identify one of them is an algebraic function and the other one is a trigonometric function. Now we need to find the integral of x sine pi x. In each case, although x sine pi x, we can work on it using the indefinite integrals by using the Eilert rule, so that we have discussed earlier also. So x sine pi x ka you can get the value of means you can evaluate the integral x sine pi x, and then you can apply the limits of integration, and your final answer will be 3 by pi plus 1 upon pi square. Your final answer is going to be 3 by pi plus 1 by pi square after you integrate. Now if we have to integrate, let me tell you quickly how exactly we can integrate this thing. It is very simple here, but let me again do it for you. I'll expect you to apply the limits on your own, but x sine pi x, if we work out here, so we have integration of x sine pi x dx. We are aware of the Eilert rule. Eilert rule, I-L-A-T-E. So x is an algebraic function and sine pi x is a trigonometric function. Algebraic comes first, trigonometric later. So I can take x as the first function and sine pi x as a later function. So first function, integration of sine pi x, which is minus of cos pi x divided by pi, minus whole integral of d by dx of x, which is 1, into integration of sine pi x, which is minus of cos pi x divided by pi. And what we get from here is minus x cos x upon pi, and this plus remains as it is. I can write 1 by pi outside. Cos pi x as integration sine pi x divided by pi. So what we get from here is minus x cos x upon pi plus 1 upon pi square sine pi x. So let me make the correction here. This is pi x, so it will remain pi x here also, and it remains pi x here also, right? So once you get this as the expression for the indefinite integral, remember we are using it in case of definite integral, so we haven't written plus c here. So this must be operated upon by the limits of integration between, let's say, minus 1 and 0, then 0 and 1, between 1 and 3/2. On simplification, you should get your final answer as 3 by pi plus 1 by pi square. I'll leave it as a homework for you, and you can get your final answer as 3 by pi plus 1 by pi square. So over to the seventh sum here.